Have you added those two together? Sine A cos B plus sine B cos A. And then the other one is sine A minus B, which is sine A cos B minus sine B cos A. So if you add these together, you'll get sine A plus B plus sine A minus B equals 2 sine A sine B. Or if you prefer, you can have sine A sine B equals a half sine A plus B plus, oh, sorry, thank you. No, this is cos here, and so here. All right, think of the next one. Cos sine A minus B. So this is actually a new formula for this class. And if you think about it, what this formula lets you do is it lets you take a sine that's multiplied by a cos and write it as a plus instead. So in other words, it changes a multiply into a plus. So a very simple example would be something like sine, 2x cos 3x, for example. That would be a half sine 5x plus sine, what goes here? Minus x. 2x minus 3x. See, this one here is a plus b, and this one here is a minus b, and this is the a, and this is the b. I'm using this formula. Does anybody know or remember what sine minus x equals?
Sine minus x?
Yep. I can do one more here. Ready? Yes. Why? I'm looking for a keyword here. Why? Why could I do this?
Because you can't put the negative number.
Students, children. No, not children. Because sine is odd. It's an odd function. Yeah? Remember we did even and odd functions?
Yeah.
Sine is an odd function, so you can take the minus out in front for sine. Where do you think such a formula would be useful? Where do you think such a formula like this, that lets you change a multiplication into addition, where might this be useful? For what type of problems? No? Any ideas? No? Well, if I ask you to integrate this, what rule would you need if it's a multiplication? By parts. You remember this? By parts? Do you need any special rule for this problem? No, you don't. This would be minus cos 5x over 5, and then this one here would be plus cos x when you integrate. So the reason this formula is useful, it is useful because it makes difficult integrations easier. And other reasons too. Okay, I would like, this is sine cos. So there's two other possibilities we could have. We can have sine sine and cos cos. I would like you for a minute to try and give me a formula for, let's see, we'll do cos cos next. Try and get me a formula for cos cos. It's the same idea. Yeah, cos A cos B. Give me a formula for that. You got one? Shouldn't take you too long. The key thing here is to realize which formula you need. You need the cos A plus B. Cos A plus B is cos A cos B minus sine A sine B, and then cos A minus B, cos A cos B plus sine A sine B. Now, what do we do? Well, we add them together again.
2 plus cos A plus B.
Yeah, on the left it will be cos A plus B plus cos A minus B. And you're correct, on the right, 2 cos A cos B. So this gives us our second formula, cos A cos B equals a half. Whoops. Cos A plus B plus cos A minus B. Oh, by the way, I'm nearly 100% sure that these formulas are not in the formula book, and I'll open up the formula book now in a minute. Why don't you try and give me sine A sine B now, and we'll have a look at the formula book if I can find it here. Yeah. Do you have this? You have this, okay. Yeah? We have this? Whatever. Maths formula book is not in this location. Formula book, here we go. Right, let's have a look at what formulas you do have for trigonometry. So trigonometry is section E. Yeah, let's just make sure it's not on the other page. Right, so if you look here, you have some. This, you know. This, you know, and this, you know. This is the double angle, which we did in the last class. This is also a double angle, which we did in the last class. And these are the 6 compound angles. But notice how there's no, the formulas today are not here.
Yes.
So you'll have to, I don't recommend memorizing them, I just recommend remembering how to make them from using the compound angle. Okay, do we have the last one?
Sine A, sine B?
Yeah.
Yeah, it will be...
What do you have to do different to get that one?
Like instead of adding them, we negation.
Minus, yeah. So we subtract them instead. So we get now, here when I subtract cos A plus B,
Minus 2.
yeah, minus cos A minus B equals minus 2 sine A sine B. So we now have sine A sine B equals a half cos A minus B minus cos A plus B. See, the minus will flip them around.
The minus of flip.
Yeah, this minus, I put it on the left to flip it around. There are 3 product formulas. Okay, so I'll do a few types of problems now. Now, mostly we want to go from the left to the right, although sometimes we do actually want to go from the right to the left. Let's have a look at some examples. So what we'll do is we'll have sine 3x sine 2x cos 3x cos 2x sine 3x cos 2x, and we want to write these as sums. So the formula here is a half. Which one is the sine A sine B? What do we have first?
Minus half.
No, what's the formula? Sine A sine
minus B.
cos A minus B, is it?
Yeah. And then
So that would be cos x A minus B.
Yeah.
And then plus or minus next.
Minus.
And then,
And then A plus B. Plus A plus B.
so 5x here, yeah?
Yeah.
Are you sure about that?
Yes.
Alright.
You just do.
Alright. Oh, this is the one that's backwards, yeah. And then this one here is a half,
This is A
cos
plus B plus A plus B.
plus
Yeah. And then minus.
x, yeah. And then this one here is sine 5x, a plus b, plus x. Yeah. Okay, next now. I'll give you a couple to try, but this time I want you to go backwards. So I want you to write these as a product. Well, I'll just give you one to start with. So write this as a product. We'll say sine, let's say sine x plus sine 2x. No, 3x. So what I want you to do here is to go backwards. So this is a little bit tricky, but not impossible, to try and go back to the original product that made this. I'll give you a minute to try this, a minute or two. There'll be a fraction in it for sure. I think so. Try it. You can know if you got it right because when you use the formula on your answer, it should give you this as the answer.
to do it like sine x cosine.
Yes, should be one of these. Now that I think about it, Luke, I don't think there'll be a fraction in the answer, except for the 2, yeah. Let's have a look at this now. So this problem is made a lot easier, firstly, if I write them backwards. Sine 3x plus sine x. Also, what I'll do is I'll put a 2 here, bracket, a half, bracket, sine 3x plus sine x, bracket and bracket. The 2 and the half cancel, but the reason for the half here is for the formula. Makes it a little easier to see the answer. Now I'll change this into 2, bracket, a half, sine 2x plus x plus sine 2x minus x. Now look at what I have on the inside here. If you look really carefully, you can see that I have a half sine a plus b plus sine a minus b. And what's that? This one here is sine a cos b, is it? This one here is, I'll do it in red again. In red, this piece here will be sine A cos B. And we can see what the A is. The A is 2x, the B is x, and of course the same should be true here. The A is 2x and the B is x. So I have as my answer 2 sine A cos B. You got cos minus x, but cos minus x equals cos x, because, very good, somebody's listening. Did you get sine minus x, or just, no? Sine 2x, okay. Oh, you didn't swap them at the start? At the start I swapped them. You didn't do this? Yeah.
So the 2, we don't cancel the half.
No, leave it there so we can use our formula. Because the formula has a half in it.
Yeah, but I think like multiply by 2 this side.
In the formula? Yeah, that's okay. Yeah, that's fine. That's fine. So a few moments ago, I said you might want to use this rule to change a multiplication into addition to make integration easier. So can you think of a situation when you want to do this? You change an addition into a multiplication. Yeah, like I did here. When might this be helpful?
But we have something with the other side, like,
Go on, yeah.
like if this equation is equal to this.
Good, I think basically that's it. If you had, for example, here was, imagine instead, equals 0, equals 0, equals 0, equals 0, equals 0, equals 0, equals 0. No, this is not so difficult to solve because you can have two answers here. You can have sine 2x equals 0 and cos x equals 0. So it's useful for solving equations. Yeah. Nancy, look there a sec.
I have a question,
Yeah.
Mr. Stephen. Like,
Yes.
in the exam, for example,
Yes.
if I know the equation, I can find the answer.
Directly?
Yes.
If you are confident you remembered the equation correctly,
Yeah.
it's okay.
Yeah, but I mean for the steps, like for the marking.
Well, this is the thing. If the question said show, then you need to show the steps. But if the question was just said something like solve this, and you use the formula directly to skip one or two steps at the start, that would be okay. Would you write down the formula though? Like use this formula?
No, you mean just write the answer.
Directly. It's okay, but I wouldn't recommend it. At least write down the formula you're using. If you're not going to prove the formula, you should at least write the results down. Yeah. Okay. Let me give you another one to try. Can I scroll down now? Yeah. Okay. So I would like you to write this one as a sum, as something plus a something. So first step, correct. Problems? Yeah. Sine x multiply sine x.
Not like sine 2x.
No. No. You got an answer? Yep. You're confident it's correct? Why not? Okay, let's have a look. So this equals sine x, which equals 2, bracket, a half, sine x, which equals 2, brackets, a half. Right.
What do you mean by that?
I've done something. I'm sorry, I forgot what I was doing. Silly. This is our formula, sine A, sine B. The only thing that's interesting is in this one, A and B are the same. Okay, what's our formula? It's a half cos A plus B, or so it'll be cos x minus x. Next. So a plus b here, so x plus x. So this is a half, cos 0 minus cos 2x, which is a half 1 minus cos 2x. You got that? And again, think about how useful this is, because when we did this last week, what did we have to use to do this? It was integration by parts. But now we can just integrate this if we wish instead. Easier to do.
This has to use like reduct rule.
No, wait, this one?
Yeah.
By parts rule. By parts. No. That's for derivative, yeah. Whereas this one here would just be a half x, well, if you leave the half out there, it would be x minus sine 2x over 2 plus c. Yeah. The antiderivative of cos 2x is sine 2x over 2. That's what you're asking, wasn't it? The minus. Because you integrate minus cos, that's minus sine. You might be thinking when you find the derivative of cos, or minus cos, that is sine. Don't worry too much about that, Yusra, because these plus minus stuff, they're in the formula book, derivatives here, and integrations here. Okay, anything else? Okay, so I'll give you 10 minutes to work on these questions in the book, and then we'll go to the next lesson. You don't need to write down the integration part, because we'll have another lesson on using these rules for integration. So you don't need to write the integration bit down.